Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 80 in our incredible new tutorial series where you're unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at SunFounder. SunFounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to teach you is I'm going to teach you how to incorporate timers into your Raspberry Pi Pico W projects. What are timers? Timers are useful little functions that allow you to synchronize different parts of your program without generating blocking functions. Now, you remember we ran into this before where we had two LEDs and we wanted to blink one slow while blinking the other one fast. So this one is going slow while this one is going fast, and they're doing that at the same time. And what we found is that when you do a time.sleep, that freezes your whole program, and so you can't have one LED blinking quickly while the other one is blinking slowly. Now, in that earlier lesson, the way we solved it by using dual cores. And so we could run one LED on one core, we could run the other LED on a different core, and we could solve the problem that way. Now, a bunch of you rightly pointed out is, you don't want to waste a core on just doing a simple timing thing. You want to use timers to do that. But the thing is that I was just looking for an example to show you how to do dual core programming. And you're right. In fact, it's better to do timers. But at that point, I hadn't taught you about timers yet. So what are we going to learn today? We are going to learn about timers. But where do we need to start? We need to start by building our circuit. So I will switch over here and I will get out of your way. And we have a very simple circuit. We have three LEDs, a red LED, a green LED, and a blue LED. The long leg of each LED is pointed to the right, and I have the long leg of the red LED. I have the long leg of the red LED connected to GPIO pin 16. I have the long leg of the green LED connected to GPIO pin 17, and I have the long leg of the blue LED connected to GPIO pin 18. Now, the short leg of each one of these resistors go down to the ground rail through a 330 ohm resistor, and then I create the ground rail here with physical pin 38 creates the ground rail, and this has the circuit hooked up. Now, I've created a power rail here from 3.3 volts. You really don't need that for this project. It's just a habit. I always create a ground rail anytime I'm going to do something. So that is the circuit. So now what we are going to do is we are going to call up Thonny. So I do need you to fire up your Thonny, and we're just going to jump in and we're going to start by just writing a really, really simple little blink the red LED program. Okay, so what are we going to do? We are going to come over here, and I am just going to write a quick program from machine import pin like that, import time, and then I'm going to say red pin is equal to pin 16, GPIO pin 16, we said. Then the red LED object is equal to pin, which pin? The red pin. And what is it going to be? A pin dot out. Okay. Now, what are we going to do? We're going to create a while loop, while true. When it's true, true. True is always true. So we're going to turn the red LED on, red LED dot on. Okay, now we're going to time.sleep, and we'll leave it on for 2 seconds. Okay, and then we're going to do a red LED dot off like that. And then how long will it be off? Red dot, or not red, time dot sleep for 2 like that. Okay, for 2 seconds like that. Okay, so now what we're going to do is we're going to come over here, and what I need you to do is keep your eyes on the red LED. I will need you to hold your breath. We're going to run the program, and boom, on 2 seconds, off 2 seconds. Pretty simple program, but man, we'll take our victories when we can get them. I get my confidence up where the first program runs like that. Okay, so that's very good. Now, what if we wanted to blink the green LED? Well, I could blink the red LED on and off, and then on and off, but I can't be doing the green one fast while the red one is going slow at the same time, because this time.sleep locks up the entire program. Okay, now like I say, I showed you how to solve this program by doing dual core programming, by putting part of the program on that other core, but I'm going to show you another kind of simpler way to do it today, and that is going to be by doing timers. Okay, well, if we're going to do timers, let me see if I can quit this program here. So I'm going to come here and I'm going to Control C. Okay, so I killed the program. Now what we're going to do is we're going to come in and show you how to do a timer. Well, if we are going to do a timer, what are we going to need to do? We are going to need to import that method. So from machine, we're going to import timer with an uppercase T. Okay, so that's good. So now we can create a timer object. And so what am I going to want to do? I'm going to want to blink that red LED, so I'm going to create a red timer. You can call it kitty litter box if you want to, but I think red timer is more descriptive. And what is it going to be? It is going to be the method timer that we just imported. And then what are we going to do? How often do we want to time? Well, it's going to have a period of, let's say, 100 milliseconds. Okay, so what would that be? The period is in milliseconds. Time.sleep is in seconds, but the period function here is in milliseconds. So 100 milliseconds would be 0.1 second. So something is going to happen every 100 milliseconds. And what do we want the mode? How do we want this to run? We want it to run as time. I better do something here, or you're going to very soon not be able to see what I'm doing. Let's see. Okay, I think you can see that. Okay, so now what do I want the mode? Timer dot periodic. What does that mean? I want it to do it every 100 milliseconds. Now what I could do is I could do it a one shot, and if I did it a one shot, it's going to do it one time. But if I do it a periodic, it's going to do it every 100 milliseconds. If I did a one shot, it would wait 100 milliseconds and then it would do it. Okay, so now let's do that. Okay, that looks good. And I say do it, do it, do it. Do what? And I better put a comma in here. Doesn't count as a mistake if you catch it before you run it. Okay, now what do I want to do? I want to get a little further out of your way so you can see my code. What am I going to do? I'm going to run a function. I'm going to run the callback function. And what is the callback function? It's the function that this timer calls every what? Every 100 milliseconds. So I'm going to call back a function called red blinker. You say we don't have a red blinker. Indeed, you are right. We don't have a red blinker. So we're going to come up here. And what are we going to do up here? We are going to define the function red blinker like that. We're going to create the function red blinker. Okay. And then what is red blinker going to do? It is going to get from the timer, is going to send it a parameter source. Don't worry about that, but just put that in there like that. Okay, it doesn't really do anything, but we've got to have it there. So that is source. And then what are we going to do? We're going to get our red LED, and then we are going to toggle it like that. We're going to get the red LED and we're going to toggle it. So every 100 milliseconds, every 1/10 of a second, this timer is going to call red blinker. What is red blinker going to do? It is going to toggle the red LED. Now we're going to come down here in this nonsense. What we're just going to do is we're going to say pass. Now, would I really be passing? Would I really be passing in the real program? No, I would be doing my program. But what I'm just showing you is I'm doing the whole blink function without interfering with my while while loop. So I will need all eyes on the red LED. We will come up here and we're going to run this thing. I will need you to hold your breath. Look at that. Giddy up. What did we do? We are blinking that red LED. We are blinking that red LED simply using a timer calling a callback function. Now let me show you the power of this. Let's say I come in here now, and instead of passing, what if I come in here and say what if I come in here and say time, okay, I say time dot, or what, let's just say here, okay, I'll just do something silly. I'll say x is equal to 0, and then I am going to say time, I'm going to say print x like that, and now I'm going to say time dot sleep of 1 second, okay, and then I'm going to say x equal x plus 1 like that. Now let's run this, okay, so I'm going to stop this, okay, now I'm going to run it, okay, 0, 1, okay, do you see this counting action that's going on down here every second? While at the same time this is blinking fast. So what you can see is this time.sleep is not blocking the timer. So the timer can keep its own time and is not being interfered with something like a time.sleep or other functions which we might be doing. Now what you noticed a while ago that is not good is when I stopped it, what do I have? I have this red LED still blinking, and you really don't know what is really going to happen, because what very well could happen is you can sometimes end up with, it seems like that timer is still running even though you stopped the program. So we need to be a little bit cleaner in the way we write this program. And I think I've shown you this before, how to do this, but what you do is you create a try and except. So I'm going to say try. Okay, what am I going to try? I'm going to try to do a while true, okay, and it's always going to be doing this while true until it runs into an error or something causes it to crash. And when something causes it to crash, it's going to do the except, and I'm going to do a specific except, which is except keyboard interrupt. Make sure that you see the K is uppercase, the K is uppercase, and the I is uppercase, keyboard interrupt. So if I hit Control C while the program's running, it's going to run down to keyboard intercept. Keyboard interrupt. Now, what am I going to want to do? I want to stop that timer. So I'm going to say red timer, and then I'm going to init it, de-initialize it, okay, like that. And then what I'm going to do, I'm going to do red LED dot off. So what do? I deliberately, explicitly, mindfully stop the timer, and I'm going to then turn off the LED. So now let's run this and see what happens. That looks good. Okay, I'm going to run it. Okay, what you can see is I've got the red LED blinking. I've got the counter working. And now watch this. I'm going to do Control C, and what does it do? Boom, it ensures that you have the red LED off. Well, this is no different than what I did earlier, just doing a time.sleep. Okay, this is no different than what I did just using turn it on, sleep, turn it off. But now what can I also create? I can create a green pin, which was pin 17, a blue pin, which is equal to pin 18. And then I can come down here and let's just do a little quick copying and pasting. Okay, so I've got a red LED. I'm going to have a green LED, which is going to go to green pin. And then I'm going to have a blue LED, which is going to be going to a blue pin. And then what am I going to need? I'm going to need to get out of your way again. Okay, and so now I'm going to create more than one timer. So I had red timer. I'm going to create two other timers. This timer is going to be blue timer, and that is going to then need to call blue blinker, and we'll have to create some new functions. Blue blinker, and then green. I am really struggling with green today. Green, and that is going to call green blinker. Now let's come up, let's snag this. Okay, and then we're going to come here and we're going to have that. And then we're going to have that. This is going to become green blinker, and that will what? Green toggle. And then we are going to have red, green, blue toggle from who? Our friend, the blue blinker, like that. Okay, so now I've got these all going at the same period. We'll start there, but then I'm going to come down here, and what am I also going to need to do? I'm going to need to de-init those other two timers. So red, green timer will be de-initted, red, green, and then blue timer will be de-initted. Okay. Also, what am I going to need to do? I'm going to need to copy this, paste it a couple of times, and I'll turn the green LED off, and I'll turn the blue LED off. All right, let's run it. Look at that. Oh, Mr. Green LED is not happy. What happened there? That's amazing. What did I do? Okay, I've got green LED as green pin. That looks good. Green pin is 17. That looks good. Red LED, green. Green. Let's try green there. Hopefully you guys caught that. Let's run it again. That one kind of scared me. Okay, red, green, blue, they're all blinking, each one on their own timer. Okay, but now let's make this more interesting. Let's do this, let's do the red at 100 fast. Let's do the, do I have that right? What did I do? I did red, blue, green. No, I can't have that. Okay, I always have to do red, green, blue. What was I thinking, RGB? I always put them in the same order. You call it OCD. I call it good programming. Okay. Red, green, blue. So the red is going to blink at 100. Let's say that this one is going to blink at, that's 100 milliseconds. This one is going to blink at 1,000 milliseconds, which would be, that would be like 1 second on, 1 second off. And then the blue, we're going to go at 10,000. So that's going to be 10 seconds. So what am I going to do? Am I going to stop the program? No, I'm going to be a good guy and I'm going to put Control C, and that stops my timers and turns everything off. So I exit the program cleanly. All right. Going to come up here more to my intermediate size. And now we're going to run this thing. And now watch. Look at that. Very fast. The green is medium. Okay, the green is medium and the blue is going very slow. The blue won't come on until 10 seconds. Okay, and there it is on. And so the blue is going 10 times faster than the green, and the green is going 10 times faster than the red. So you see, I now have the ability to control things and to control the timing of one thing separate from the timing of another. And then you can see down here in the main program, it is doing its own thing unaffected by those three timers. And so that is really what we were wanting to learn today. And you can create, I don't know if there's a limit to how many timers you can create, but you can create a lot of them. Maybe you can create 16 different timers. I am not sure if that is really a limit or not, but I know it will work for at least 16 different timers. Okay, so let me see here. Let me think about what we are doing. I have shown you that. Okay, let me show you one other thing here, all right? Let me show you one other thing. Let's just say that what if I wanted the blue to just come on after 10 seconds and then not turn off, or, not keep calling it, right? We're calling these functions periodically. It means it keeps calling it every time after the period, then it calls it again. Okay, but what I want to do is, what if I just wanted to turn the blue on? So up here, I'm just going to say blue on, and I only want to do it one time. So what you're going to do is, instead of saying timer dot periodic here on the blue one, I'm going to say timer dot one_shot, like that. Okay, now I'm going to Control C to exit the program, and now I'm going to run this, and then you can see the red is blinking, the green is blinking, 2, 3, 4, 5, and then the blue comes on, and the blue stays on. Why does the blue stay on? Because I only call it one time. How can I really prove that? Let's go back. I'm going to Control C. What if I did, in fact, here say toggle? Okay, and that'll prove that I'm only running it one time. Okay, so let's run it again. Okay, so there it is. And now we're watching here for the blue. And the blue is going to come on, and then that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it never, that blue timer runs one time and then it sort of disappears. Okay, well, let me come over here. I think I need to give you guys some homework. So I'm going to Control C out of my program, and I'm going to give you guys a homework assignment, okay? How come that didn't Control C? Control C, there it is. Cleanly exited the program, okay? Now, what I'm going to do is, I'm going to give you a homework assignment. All right, now, give me just a second to get a little work done here. Okay, now what I want you to do is I want you to watch this red LED. Now, how were we doing this? We were going toggle, toggle, toggle. All right, I'm going to give you a really simple assignment. So if I said 1,000 for the period, it would be on 1,000 toggle, off 1,000 toggle, on 1,000 toggle, off 1,000 toggle. Okay, but now I want you to make it do, this. Instead of being uniform, I want you to make the red LED, come on for 100 milliseconds and be off for 900 milliseconds. So I want on, off, on, off, on, off, and I want it to be uniform. Okay, so this is what I want you to do. Now watch that red LED, please. Okay, on, off, on, off, on, off, on, off, on, off. And the green is still going about its business normally. The green is still blinking on for a second, off for a second. The blue is still staying on for 10 seconds and off for 10 seconds. But do you see how I have an asymmetric blink on the red? And so that is your homework assignment. Now, what have I done? I've given you a group of tools. I've given you a batch of tools to use. Now, what do you need to do? Once you see me do it, you're going to see that it's really easy. But what's the biggest problem that you have? Of these tools you have, which tool do you need to do to get this type of behavior that I am showing here? Okay, so I hope most of you guys will get this. Some of you it's probably going to be real easy, and others of you it's going to be probably a little bit more of a challenge. But anyway, I hope you'll have fun with it. Make sure when you do the video, you post it to YouTube. When you do, leave a comment down below with a link over to your homework solution, or if it's not posting links for you, just say, hey, I've got my homework solution up. And then in your homework solution, in the description, make sure that you link back to this video so people will have context. And then I'm hoping that you guys, now that we're on lesson 80, I'm hoping you guys are getting more adept in your programming, and I'm hoping that at least half of you guys can get this homework done. But if you can't, never fear, I'll show you next week how to get it done. Okay, guys, I hope you're having as much fun taking these lessons as I am making them. Remember that it always helps me if you give me a thumbs up or leave a comment down below. If you haven't already, make sure you subscribe to the channel. And as always, I want to give a big shout out to you guys who are helping me out over at Patreon. You guys are keeping me in the game. Thank you very much for your support and your encouragement. And most importantly, remember to share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys